This sequence illustrates the exact problem with posting images online today. Every platform demands a different shape. Instagram wants 1x1 rigid squares. Pinterest demands a tall vertical 2x3. YouTube requires exactly 16:9 widescreen. You capture one great photograph, and suddenly you have to contort it into a dozen conflicting dimensions. For anyone managing online content, this means opening photo editing software, manually adjusting the crop box, exporting the file, and then repeating that exact process for every single network. This diagram shows what happens when we automate the process using standard tools. Most autocroppers are blind. They target the exact center of the image mathematically, invariably cutting the main subject right in half if it rests off to the side. Preparing visual assets is a strict geometric math problem. The existing rigid software tools simply lack the intelligence to solve it without ruining the composition. SmartCrop Agent approaches the math differently. Built for the Kaggle Vibe coding capstone using Google Anti-Gravity, it runs locally, entirely for free, without requiring API keys. Instead of cutting blindly, it analyzes the pixels to calculate the actual subject of the photograph. Once it knows what to look at, it applies established rules of photographic composition before making a single cut. It achieves this through its architecture. The system operates as a coordinated team of 3 specialized AI agents, rather than one massive, slow application. By dividing the labor into specific roles, the system balances the need for careful aesthetic judgment with rapid computational speed. The workflow begins in the browser. You drag and drop your image files directly into a dark, frosted glass web interface. The moment those files upload, the first component wakes up, the orchestrator agent. Think of the orchestrator as the project manager. It accepts the user's inputs, manages the system state, and immediately passes the images along to the right subagents without waiting for further instructions. That sleek web design is actually a dashboard sitting on top of an active, asynchronous manager running entirely on your local machine. Back on the dashboard, a canvas appears. Almost instantly, a crosshair renders on the screen, locked precisely onto the primary subject of your photograph. This calculation is the work of the detector agent. It uses a technique called saliency analysis to figure out what matters in the frame, identifying areas that should naturally draw a viewer's eye, and it does it all offline. This diagram illustrates the first of 3 signals the detector uses. It looks for edge energy. By analyzing abrupt changes in pixels, it maps the distinct boundary of objects against their background. Next, it layers on color contrast. The system isolates regions that differ heavily from the average background color, glowing brightest where the visual separation is the sharpest. Finally, it applies a subtle center bias, favoring objects closer to the middle of the frame. It fuses these 3 signals, weights the data, and locks on to the exact weighted centroid to determine the absolute focus point. If the math doesn't quite match your creative intent, you simply click and drag the crosshair. The system follows your cursor in real time. Pairing deterministic algorithmic detection with a manual override ensures human aesthetic judgment always has the final say. With the focus point set, you move to the preset menu. You select Instagram Square, LinkedIn Banner, Twitter Post, and click Process. The final component steps in, the cropper agent. Its job is to cut the image, but it operates strictly under the rule of thirds, a classic compositional guideline where subjects are placed off-center to create more visual interest. As you can see in this grid diagram, placing a subject perfectly dead center often looks amateurish. The cropper actively snaps the focus point to the nearest intersection on a 3x3 grid, forcing a professional composition. Behind the scenes, it utilizes Python's thread pooling. Instead of calculating the Instagram crop, finishing it, and then moving to Twitter, the system shatters into multiple operations, launching every single aspect ratio simultaneously. Because these tasks run concurrently, computing 15 different aspect ratios takes the exact same amount of time as computing just one. The progress bar fills, and a responsive grid populates the screen with perfectly proportioned images. Clicking into any result opens a before and after slider. Dragging it back and forth proves the subject is still firmly anchored in the visual hierarchy, regardless of how aggressively the image was resized. One click downloads a single zip archive containing every variation. A repetitive, multi-hour workflow of manual adjustments collapses into a localized, automated action that finishes in seconds. SmartCrop Agent solves a specific frustration, but it also serves as a direct application of the multi-agent design patterns taught in the Kaggle Vibe coding course. By breaking a complex creative task into specialized, delegable steps, orchestration, detection, and execution, the application remains modular and easy to maintain. This entire privacy-first utility was developed through agentic coding within the Google Anti-Gravity IDE. This architecture demonstrates how coordinating small, specialized AI roles can solve nuanced problems that rigid, top-down programs often struggle to handle.